API with Python and different techniques which might help us to build better API. A little bit about myself. I have like 12 years plus experience with different languages, 7 years with Python, and also I have 6 years with JavaScript. I worked for Odesk, which is Upwork now. Helios Technologies, it's a huge porn portal, and if you heard me, other companies. Also, I participate in organization of different conferences in Ukraine, like PyCon Ukraine, Kiev JS, Papers We Love, and a whole movement CityJS in Ukraine, and CTPy. And I'm working as CTO for CarTrash. And this time, this is my first talk in English, so bear with me, guys. It's not my first language. About my job, I'm working for CarTrash, which is grocery delivery startup. We operating in both United States and in Ukraine in 3 cities, which is Kiev, Kharkov, and Dnipropetrovsk. Our stack is quite simple. There is Apache CouchDB, Apache Solar, and Redis. And also we have a huge amount of Python code, which is obvious, yes. In my talk, I'm going to split it into 2 different levels. The first level is very like generic and about life and about APIs and how it works and why we need it. And the second part is very specific tools which we have in Python, which we can use and which might help us to build API. So why we need to talk about API again? The first reason is that world is changing very quickly, and we have now a lot of mobile apps around. We have a lot of new devices. Internet of Things is hype today, and a lot of companies switch from monolith models into microservices models. So they should, the microservices should talk to each other for using some API. And another reason is, I think, is huge reason nowadays is isomorphic apps, which requires to have same state for client and for server to render correctly with JavaScript on the server. For my opinion, good API is hard because when all your stuff should work together well. What is challenging there? For sure, it's data validation. For sure, it's reusability, because it's hard to hard to build thing which others will use, not build the thing again, not reinvent wheels. If you build not convenient API, then nobody will use it. It's hard to keep API consistent, because today you deploy a new version on production and not update your docs, and you fucked up. It's hard to build, to maintain good API, especially if you have microservices architecture, and it's hard to be consistent to not break other services if you deploy your service API. And it's quite hard to scale, but it's another problem. So why we need good API? And good API makes it easier to develop good services, new services. So what we do with hard problems, how we solve it? The strategy is to divide and conquer. So split into smaller parts solve it separately, and then it will be solution of your problem. A bit about what is API, what I mean by API. API, like its definition from Wikipedia, I believe, it's expresses a software component in terms of its input, outputs, underlying types, and so on. Nowadays, API helps us to create building blocks of software. So like API 20 years ago or 30 years ago was pure part of software, like functions or objects, or I don't know. Nowadays, by API means usually something which client server, server, communication, protocol, and so on. And also API might help develop new products, see your product under on other angle, using your existing abilities of your product. What is moving parts of an API? First of all, it's obviously input, validation, business logic, and output. Everything is important in order to build something which might be reused, might be useful, and might be usable. So what was like in details about input? Input need to be valid. You need to handle all types and ranges and other things. By validation, it's like should be correct. Validation, it's something is like your set of your params, input params should constrained by domain-specific business rules, like not duplicate emails or anything else. Obviously, business logic is, I believe there is nothing different from any part of any other software, something domain-specific. And output should have some data model. You need to serialize it in some format, and probably you need to aggregate or, I don't know, filter it and so on. You should have like some abilities to provide data which required by client. So if split this problem into separate one, they are quite trivial. So I like can say a lot about these tools which we need to in order to solve this particular part separately. Everything is trivial. But what is hard is to combination of tools which make us able to be to keep API consistent, synced, to see different deprecations, to not reinvent wheels, reuse the code or all the API on piece of code, to compose different parts of API and everything in the same time. So trends which I like feel the past few years. The first trend is total RESTification. Everything is REST. REST is must-have. We have beautiful tools, document generation, frameworks to generate specification, and so on. And it's a hype now. Another thing is data query languages, which is the best example is GraphQL. I believe everybody familiar with it. And who don't know what is GraphQL? Okay, cool. I will tell more later. And microservice architecture. So about REST, why is like so huge thing right now? I think before REST, everybody like do what they want. They use JSON payloads, response and JSON, and nobody cares about unified data, error handling, and so on. So when REST came into scene, we got like a huge unified interface to work with different API, which based on top of HTTP, which make things curlable. You can use URL to work with API, and it's very simple. So another thing is data query languages. I'm aware about at least 4. The most famous right now is GraphQL. Other one is Falcor by Netflix. Datalog is the language which you can which you converted into convertible into different SQL dialects, and Datomic, which mostly inspired by Rich Hickey, the author of Clojure. Main point of DQL is to make declarative composition of queries to different simple APIs and compose from these different simple API the one single data structure which can be useful for clients or for mobile app, or to not make, in other words, do not make a lot of requests, different requests, and then aggregate it into your application. The simplest example of communication between agent on this picture is user agents like browser and API server. Microservices. I will start with this picture with represent monolith application. I prefer to call it a huge piece of shit. And the shit is sad because it's hard to maintain. Everybody is familiar, probably, I'm sure, with huge obsolete application and work with them, which is not without tests and different things. So it's like more realistic example of how people build with monolith services. I work for the company which had such service. They had dedicated team to make this work, make this not like error, make fail every day. So the dedicated team working only on stability of this API server. And it's like that. The load balancer location server is just for performance. The code itself still monolith and it's hard to maintain. So this company built microservices. They split the huge piece of shit into piles of small pieces of shit. So now they have a lot of work to do. And as you understand, between them, different APIs. So they have additional level of complexity. I should say that there is some difference. Small pieces of shit, smiling. But seriously, microservices add new layer of complexity, at least in terms of input validation of every microservice, and in terms of unreliable layer, which is network. So if microservices fork with each other, they add a lot of latency to your application. And also you will add like additional complexity with protocol overhead. Like you should get input, convert it into your specific format, language, in this case Python, then do some things, and then convert back into JSON or XML or anything like that. But the advantage of this is that you should deal with this a lot of small pieces of shit only once. When you split your huge monolith service, you can improve every microservice separately. So it's a huge opportunity to make your service more stable, because you have 5 services, 5 dedicated teams, which can improve in same time these different services. And the only task is to be synced enough to not break things during this improvement. So what tools we have to achieve this in microservices or in API to be synced, to be consistent? The famous one at this moment is Swagger. And it became so popular that now they renamed to Open API Initiative, and they moving towards like one single standard of representing REST API in format of Swagger, and convert into different languages using templates. So, because there's declarative style of RESTful API. So another one thing is RAML, a RESTful API modeling language. It's competitor to Swagger, like direct competitor. So they do absolutely same things, but in different ways. There is plenty of others. I just for letting you know that there is API doc, API blueprint, and so on. There is partially covered this problem. So one covers like documentation, specification, and bunch of other things. But most popular, there's 2. Here's example of very explicit Swagger specification. So the idea is that you open the tool called Swagger Editor, and you wrote down this specification. There is validator and preview of your API and docs generation and blah blah. And after that, you generate code of this API for your code of this description of API after specification into your specific language, your application, and it's shareable. So you can like once describe your API, and then you can use it for mobile application, for Python API, and so on, and everything should work together. So here is example of RAML specification. So as you see, there is not a lot of difference. So just another notation. But RAML is more verbose. So 2 slides for RAML. So it's quite like meaningful. So you start with description and blah 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 and schema and so on. Everything looks like you described your only one data point. So it's very explicit description. So again, the main idea to be consistent, to prevent situation when your client using your API and something broken and there is no mention about update in your documentation or deprecation warnings or anything like that. So to prevent like be out of sync. It's especially painful for mobile application when you like create new API of your web service, API server, and mobile application not deployed yet, and with iOS applications it's very painful, like you need to wait 2 weeks of review before it goes to production. So you like might have situation when you are down for hours if like somebody deployed on Friday evening update and clients are not happy. So another aspect of API, which is very important at the moment, is aggregation. I think that it's quite simple to write it by yourself. It's a trivial problem. Like you have parameters, you have response. So everything besides that, you can use like some query language, pseudo query language, or some build anything based on Descartes algebra. Here's example of GraphQL. So I mentioned that I want to describe this in details. So the idea is that you describe your data model. Every field, everything should have type, and you can create custom fields. And after that, you create your schema. In this example, I create two fields, which hello and data, describe it here and here, and I'm getting this order dict of requested data. So it's easily converted into JSON, so you can use it in client application, mobile application, and the language itself is quite powerful. And as far as I remember, later today will be special talk about GraphQL and Graphene, library for GraphQL in Python. So I will not like go very deeply into this topic. I want to highlight only difference between GraphQL and REST interfaces. So the GraphQL language itself provides you ability to request exactly what you want, no more or less, exactly what is required by your application. For example, you have, let's say, front end, you have mobile version, and you have like desktop version of your website. There is some different client side code for these two versions, and for desktop you need huge pile of data, and for mobile version you have a small payload. So you can just write different GraphQL queries for both cases, and that's it. You don't need to pile of data for mobile version of your component. Another important topic is GraphQL with Swagger, RAML, and any other declarative approaches to describe APIs. GraphQL, and especially this library Graphene, allow us to use our beloved language Python to describe APIs, to describe schema declaratively. And it's not possible with Swagger, because the problem is that with Swagger you have Swagger editor, so you have a separated movement part of your infrastructure, moving part of your infrastructure. So you need to go to somewhere to change specification. After that, you need to follow several steps to update your API, which sounds complex. And as developers, we're all lazy. I am very lazy, and I'm not going to do that. If I can describe everything schema in Python, I will do definitely this. Another technique of it just mentioned, I want to mention batching, because it's not so obvious, and there is not a lot of like information over internet about batching requests. So as you know, the REST based on payloads, like you make a request a specific endpoint and get response. And if you're building some kind of like middle or complex client side or mobile application, you may create a bunch of different requests to different resources. So it adds a lot of latency to your application. And batching is the technique which might combine different requests into single HTTP request. go through API in parallel, and then give you one single response. It's like, for example, it's 1, 2, 3 request. Here is it splitted, and response as one single object. I found only one tool for Django called Django batch requests, which do this idea. And the response looks like that. So you have first response, second response, and so on. So that's it about batching. And now I want to give you some real examples, which we did. So we implemented batched interface in first place because we already knew, we have some experience with REST API, and we implemented the batched API interface, so you can execute multiple queries and get multiple responses for these queries. Another important part was declarative input validation. It's very similar to data models in GraphQL. So we declare what we allow, disallow, and how we transform input data params input data, and we have unified response, like if params is not correct. Disadvantage, or we don't have schema at all. So if we build some like queries to our API and change something, the query will be broken. But it's exactly the same idea like with SQL. If you delete some field from your SQL table, all requests which use this field will be broken, so nothing new. We are using, by the way, the library called Trafaret. The author of this library is here. It's Misha Klymyshyn. So the library doing the validation and transformation of structures, which you like receive as your input, and it provides the transformed output into single variable. Example of transformation is like what here's we convert everything to Unicode and strip, and here's the transformation are pretty simple here. And here's example of our query language. There is no syntax at all because I'm lazy to parse syntax. So we are using like JSON structure to let our API know what I want to aggregate, and I'm receiving this whole data structure as single response. So here is I'm making the API query to our products, then I join facets, and then I join category 3. And I get response as single huge structure which represent everything I requested. So that's it. Thank you. By the way, here's today's self-serving, so I'm going to, as organizer, I'm going to provide you a microphone. Questions? Okay. Doesn't work. So looking for a replacement.
1-1.
Super.
Thank you for your conversation. I have one little question. What about malicious clients or just stupid clients who send a little bit strange query and your service process it about 30 seconds, for example. Do you have such problems with your query languages? And
yeah, exactly. It's not. There is no like restrictions about who will do that. I can do stupid queries too, sometimes.
It could be a problem in production.
Yeah, but we should bear with that. So we have like restriction of execution time. It's obvious. So if you create very huge query, it will be like interrupted in the middle of.
Just amount.
Yeah.
So which is the average latency of your queries?
At the moment, they are blazingly fast. So there is not such problem like even user experience latency. So
no problem.
It's quite the idea is very simple, stupid, and therefore it works very predictable.
Thank you.
Any other questions?
I have C++ background, and I used to develop with protocol buffers. So
Yeah.
I've googled a little bit just right now about the GraphQL.
Yeah.
And what's the point? What's the difference of the GraphQL compared to the existing serialization protocols like Thrift, Apache Thrift?
I think it's completely different levels of. It's like GraphQL is high-level language. It's like SQL if you want, and protocol buffers and so on. As far as I understand, just serialization protocols. Correct?
Well,
it's not a query language, correct?
It's not a query language. Right?
So it's like the questions like why.
So
very different things should be compared together. Probably let's like discuss it. I mean, you can put response of GraphQL into protocol buffers as optimization. I'm sure you can do that. But I'm like, that's it. There is no more optimizations. GraphQL is a language, so you produce the output of. That's it.
But all right, but what about old school like XML? How it relates to it? You can define.
You can serialize response of GraphQL into XML, into JSON, into any format. Okay.
All right. So
it's like just it's query language. You know.
I got it.
We can discuss it later if you want in Russian. Thank you. Thank you for your question. Another one. Self-serving, remember you. Remind you.
Hello, my name is Nikolai.
Hello, Nikolai.
Thank you for your talk. I have maybe newbie questions about GraphQL. Could you show a slide with examples?
Yes.
This one I didn't see where is data variables used.
Here's how I get it. And here's
this some magic. I'm right?
it's not a magic. Just you explicitly specified that how you want to resolve this type of this field.
But data is global variable.
It's type, and it's how do you represent this type.
Oh, okay. Thank you.
So it's a very like hello world example. You can like write not only these queries, you can write huge queries like exactly like SQL, but it's not. Later will be the talk about GraphQL, so feel free to go deeper. Any other questions?
It's another question.
Shoot.
Do you have versioning of your API?
Yes.
Yeah. Like
And
like v1 select and v2 select, something like this, yeah?
Kind of.
And also you have update, delete, and some other
No.
queries, only selects?
It's API, it's not
API
like REST, it's not like SQL, it just looks like SQL because the idea is very simple of joining queries. The only thing which similar is join.
But we need to change data sometimes.
Yes,
how
and
is
there's
possible with
there's
your
very
SQL?
very simple, like the same idea as usual REST updates. So you send your payload and that's it. I validate input, change, and
Okay, thank you.
so it's really trivial and simple. It's why we love it.
Thank you.
Thank you guys for listening. Oh, another question. Sorry.
Max, as I understand, you are reading and teaching a big pool of libraries, so I will continue previous question. Are Swagger or something other support updating or changing data?
Yes. Even GraphQL have, they call it mutate queries, so you can like specify.
So when I understand how to query data, you can
It's
what looks like some update, deep updates, nested updates, or something like that.
I've not prepared, but there's like if you Google GraphQL, you will have like you will find it very quickly. As I know from guys who are using GraphQL in production that it's not very convenient to mutate data with GraphQL. It's disadvantage of GraphQL.
So it's mainly designed to query data and not to change it.
Yeah.
Okay. Thank you.
Thank you guys. Thank you for listening and have a great day.